This is part 3 of the graphing quadratic functions videos. This is the one where we're talking about standard form of the equation. Standard form is when it is in the form ax squared plus bx plus c. Now when we're in standard form, the only really obvious point that we can find right off the bat is the y-intercept, because we notice that we have two terms with x in them. So if we plug in 0 for x, both of these terms are going to become 0, and we're just going to get our y-intercept is the constant. So I'll write that out. F of 0 is 0 squared plus 4 times 0 plus 3. So the y-intercept is 0, 3. So this constant term tells me the y-intercept. So that's the only quick point I can find. I also know from here my slope is 1. Now if I want to find x-intercepts, I would have to either factor or use the quadratic formula, because if I set this equal to 0, x squared plus 4x plus 3, two ways of finding values for x that will make this equal 0 are factoring or using quadratic formula. This particular one factors, but I'm also going to show you quadratic formula because I want to show you another way to find the vertex that involves the quadratic formula. So if I factor this, it factors to x plus 3, x plus 1. So my x-intercepts are going to be -3, 0, and -1, 0. So I can plot those points. Also, I can find the vertex. So this is kind of going back to the things we talked about in vertex form, or I'm sorry, in intercept form. So let's plot 0, 3, -3, 0, -1, 0, and 0, 3. Okay, so those are 3 of the points. I also know that halfway between my intercepts, my x-intercepts, is where the vertex is going to be. So the vertex is going to have an x-coordinate of -2. If I plug -2 back into the function, I'm going to get 4 minus 8, which is -4, plus 3, which is -1. So -2, -1 is my vertex. Now I'm doing this right now just kind of quickly because we've already seen methods for graphing using the intercept form. But I want to think, now could we go back to the original form and could I figure out the vertex without having to factor? What if I couldn't factor? So let's think about what happens when we use the quadratic formula. In this case, when I use the quadratic formula, let me think. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So write out my quadratic formula. Yes, thank you. You can throw money. Plugging in 1 for x, or 1 for a, 4 for b, and 3 for c, I get x is equal to -4 plus or minus the square root of 16 minus 4 times 1 times 3 all over 2 times 1. So -4 plus or minus the square root of, that's 16 minus 12, so square root of 4 all over 2. So x is equal to -4 plus or minus 2 all over 2. Now, I can simplify that, but I want to split this up and to show you that this does give me two different answers, and it gives me answers like this. X equals -4 over 2 plus 2 over 2, or x equals -4 over 2 minus 2 over 2. In other words, x equals -2 plus 1, or x equals -2 minus 1. X equals -1, x equals -3. Those are my two x-intercepts. But I want you to notice more than the fact that I just got my same two x-intercepts. I also want you to notice the vertex. Notice here when I do -4 over 2 plus 2 over 2 and -4 over 2 minus 2 over 2, when I add 1 to -2 and I subtract 1 from -2, I'm showing that -2 is in the middle. I've added 1, I've subtracted 1. -2 is in the middle. This number right here is my vertex. This number right here. This number right here. Where did that come from? If we trace that all the way back, Where did that number come from? Negative b over 2a. So if I go back and look here at my original equation, negative b, negative 4 over 2 times 1. Negative 4 over 2 times 1 is equal to negative 2. Negative b over 2a gives the x coordinate of the vertex. So that's an important little piece of information. So I want to do another example of this, because if you're thinking that, well, that's a pretty rotten way to go about doing this one, you might find that the next one makes a little more sense to take the time to do this. So if we go back to, if we go and look at the second example, this can be factored. If I want to find, so I already know this is the y-intercept. If I let x equal 0, that's my y-intercept. So I know 0, negative 5 is my y-intercept. So there's 1 point. And this actually can be factored. If I factor this, there are two possible pairs of first terms. I could use 3x and I can use 2x, or I could use 6x and 1x. To get my last term, I have to use a positive 5 and a negative 5. So for example, a positive 5 and a negative 1, or a negative 5 and a positive 1. So plus 5 minus 1. So this would give me negative 5, this would give me 6x squared, but this would be 10x minus 3x, which is 7x. That's not correct. That doesn't give me 13x. So let's try minus 1 plus 5. There'd be another way. This would give me 15x minus 2x. That gives me 13x. That's correct. So I don't need to try the 6x and the x, but that would have been another possibility. So I have found the factored form. Either 3x minus 1 has to equal 0, or 2x plus 5 has to equal 0. Now, you can solve for x in each of these, but I just want you to think. If 3x minus 1 has to equal 0, that means 3x has to equal positive 1, which means x has to equal 1/3. If 2x plus 5 has to equal 0, that means 2x has to equal negative 5. What do I multiply by 2 by to get negative 5? Or I'm sorry, what do I multiply by 2 to get negative 5? That means x has to be negative 2.5, or negative 5 halves. Okay, so I could solve that and figure it out, but positive 1/3, negative 5 halves, or negative 2.5. Now, if I go through the process of plotting these points and trying to find the middle point, the middle x value between positive 1/3 and negative 5 halves is not going to be as easy to find just visually. So I think I want to use this, I want to point out using the quadratic formula how I could find that middle term. So remember, I could just do negative b over 2a, because think about my quadratic formula. Let me split this up again. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Hope that sticks in your mind forever. Now I could split that up and say x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. When I plug numbers in for a, b, and c, I'm going to get a specific number here and a specific number here. I'm going to take this number and add that number. I'm going to take this number and subtract this number. Therefore, whatever the two numbers I get, this number is the number that's in the middle of those two numbers. This number plus this number minus that number. If I plug in some values here for this particular function, my a is 6, my b is 13, and my c is negative 5. So b is, this is negative 13 over 2 times 6 plus or minus the square root of 13 squared, which is 169, minus 4 times 6 times negative 5 all over 2 times 6. So I have negative 13/12 plus or minus. This turns out to be, if I simplify this is 169 and this is negative 120, or positive 120. So this is 289, the square root of 289 over 12, which is the square root of 17 over 12. So this turns out to be negative 13 over 12 plus or minus 17 over 12. Well, if I guess I'll kind of draw a line like this. If I have negative 13 over 12 plus 17 over 12, that's 4 over 12, that's 1/3. That's one of the numbers I found for my zeros. If I have negative 13 over 12 minus 17 over 12, that's negative 30 over 12, which is negative 5/2. Divide both numerator and denominator by 6. But once again, big idea here is that is the x-coordinate of the vertex. So all I needed to know was negative b over 2a. That gives me the number that's halfway in between my two zeros. That gives me the x-coordinate of the vertex. Once I know the x-coordinate of the vertex, I could plug it back in the equation to find the y-coordinate of the vertex. I probably would do that on my calculator. So actually I have my calculator handy. So let's go to a calculator page. And I have 6 times the, or not x, 6 times the quantity negative 13 divided by 12 squared plus 13 times negative 13 divided by 12 minus 5. And somehow that's not right. It's supposed to be just like a negative 12. Maybe, let's see if that reduces. Control, Enter. Oh, it's kind of a it's not a very nice number. So on the calculator, when I looked at it, when I graphed it, it looked like it was exactly negative 12, but it must have just been rounded. So my x value is negative 13/12, my y value is negative 12.0417. So not nice numbers, but I want you to be able to find the vertex, so I just kind of picked a bad looking one. To find the x-coordinate of the vertex, negative 13 over 12. Just do negative b over 2a. I probably won't give you one quite that nasty on a quiz, just in case you wanted to know. But I wanted you to see where that came from. Okay, there's 3 different, that's your third way, so let's just think through here. If I have an equation in standard form and I want to graph it, one way is to factor it and then go back, then use the factored form or the intercept form to find key points and find the vertex. Another way, though, is to find the y-intercept and then find the x-coordinate of the vertex using negative b over 2a, plug it back into the equation to find the y-coordinate of the vertex, plot the vertex, plot the y-intercept, and then just use symmetry. So I'll just make a rough sketch of this. Negative 13/12 and negative 13/12 is about negative, a little past negative 1. So there's my negative 13/12. And then here's negative 12.0 something. Here's my vertex. My y-intercept is negative 5. And so then I could just draw the graph using symmetry. So that's just a really rough sketch of the graph. I think I have it graphed actually over here. Yeah, that's what it looks like. So it was a pretty decent sketch actually. All I needed to know is the y-intercept, which is right here, and the vertex. And I could draw a reasonable graph with that. So there is the last one of your 3 how to graph quadratic functions. And you can see this one is the more challenging one. And often when we graph, we'll be using the intercept form. but I wanted you to know that there is a way to find the vertex quickly using the standard form with negative b over 2a.